Question 12b. Given gx as follow and x is not equals to 5 over 4, now we would like to find out the k, which is a constant, such that our gx is not a one-to-one function. So please be aware, this question is totally independent of questions A just now, where we don't imply the answer or relate the answer or any information from part A, but this is as if like a brand new independent question. The only thing common with question A is that they're still referring to the same function g here. And this time, we would like to find out what happens to be the value of k in the situation such that gx is not a one-to-one function. And how we happen to get the answer here, and how shall we start here? So the only piece of information we know is that gx is not one-to-one. So how I use this piece of information to help me? So let's think about it. When the time we want to discuss about one-to-one function or not, if you still remember, by algebraic methods, obviously in here graphical method is not really practical because the k is unknown here. So the shape of the graph, it is a lot of uncertainty. So therefore we go for the algebraic idea. So when the time you discuss about one-to-one functions in algebraic methods, what you usually do is that first we begin with the idea that x1, the gx1 equals to gx2. And then we try to go on with the calculations and try to observe whether can I get x1 equals to x2 or not. And then I come to the conclusion whether it's one-to-one or not. This is what we usually do when the time we want to prove this is the case, is whether one-to-one or not. Or in other words, I should say that we don't know whether it's one-to-one or not the function. We want to, by algebraic, to decide. But now what if this case here, I already know, according to the question, it is not one-to-one. Then what can I imply for the info here from the calculation here is that, then for sure, my x1 and x2, I won't get it equals to the same. So this is the info that we should happen to imply here. And in order to solve these questions, we will begin our calculations like something we do to determine one-to-one function using algebraic methods, where we begin with this assumption. And how we're going to relate with this information here later, that one, we shall see along in the calculations. Maybe by just looking at the framework here, you don't see how you can relate with this thing here, but along in the calculation, it may give you some idea there. Therefore, without further ado, we begin with the assumptions. We let gx1 equals to gx2, where of course, the x1 and x2 must be within the domain of G. So we substitute x1 and x2 accordingly into function G. So on the left, I substitute with x1. On the right, I substitute with x2. Go on. So now the next thing what we're going to do is that we try to simplify our terms here. And please take notes, you shall not do compare both sides because it's not, nothing can be compatible in this moment here. So what I'm going to have in my next slide is as if like the things that we call as the cross multiply. We happen to perform cross multiply, and what you happen to find out in the initial answer is something like this, for example, where you happen to see that I have this term here on the left, the numerators on the left, I cross multiply with the denominator on the right, and I get the left-hand side term. On the other hand, I have the denominator of the left-hand side, I cross multiply with the numerators on the right-hand side, I got these right-hand side terms. Then go on. I would like to do expansions here so that I can further simplify my terms. So usually this is what I will do. I will consider the first bracket, I break it into two parts. Then I multiply with the second bracket. So for the one highlighted in yellow, multiply with the bracket in blue, I suppose I will have the answer as 4k x1 x2 when the time my kx1 multiply 4x2. And then the part in yellow, multiply with -5, I get -5k x1. Continue. For the one in green, I multiply with the brackets 4x squared. Sorry, not 4x squared, 4x2 minus 5. It will give me plus 32x2 minus 40. In here, I use two different color to indicate that for you to see clearly, it is refer to x1 or x2. During your solution, you don't have to purposely make two color. Then go on. On the other side, we're going to have to do the similar thing. And this is the result that I suppose I have. Similar like the one on the left-hand side. So up to here, I have done my expansion. And now I try to see, is there any things that I can do simplification? So in here, we find out that on the both left and right-hand side terms, I have the common terms of 4k x1 x2 and also minus 40. So therefore, this common term, it can be eliminated in the next line. Or just like you people like to do, you do cancellation, you potong. Okay. So therefore, it left with minus 5k x1 plus 32x2 minus 5k x2 plus 32x1. Then the next one, what I would like to do is that if I continue and try to prove that x1 not equals to x2, it seems to be meaningless because I already know the result x1 is not equals to x2. And now I need to try to figure out from these equations here, how I imply the info x1 not equals to x2 to solve the k. So in here, let us try to rearrange all the term on one side. Let's say I move all the term to the left-hand side. What we happen to find out is that I have 5k x2 minus 5k x1 plus 32 x2 minus 32 x1 equals to 0. And if you happen to observe carefully, for the part that I highlighted in blue, for the part that I highlighted in blue, and the part that I highlighted in yellow, both of them I can happen to do factorization such that the one in blue I factorize 5k, the one in yellow I factorize 32. And further, you find out that this result here, I can further factorize where I have the common factors of the bracket terms, x2 minus x1, and further, I happen to have this result. And by right in here, I should be able to see the clue to get the answer, but before you come to the answer, I want you to take notes on the idea on the solve of the solution, the step that we solve later. So based on this thing here, what we happen to know that we have two brackets terms multiply each other, they equals to 0. So what is the possibility is that it may be the first bracket is 0, the second bracket not 0. So when the time they multiply, equal to 0. It can also be the first bracket not equal to 0, multiply with 0, equals 0. Also, it can be both of them is 0. The thing why I want to emphasize here is so that later, by the time you solve for the k value, I believe up to this moment here, you will just happen to directly solve the k that you notice that you refer to these factors here. You have k equals to minus 32 as your answer, and minus 32 over 5 is your answer. And yes, this is the answer, but what is the concept behind that I need you to realize is that if I happens to have the situations that I can allow the brackets I highlighted in green here to be 0, then it is not necessary that I can get k value as this one. Kalau bahagian hijau ini boleh sama dengan kosong, jadi saya tak boleh solve k sama dengan negative 32 over 5 because it have the possibility that kalau x2 minus x1 adalah kosong, maka 5k plus 32 is not equal to 0. And therefore, if these factors here that I highlighted in yellow now is not equal to 0, therefore it can't give me the solution, k equals to negative 32 over 5. So this is the thing that I need you to realize. And this is how we imply the info that we have just now, where this is not one-to-one function, so x1 not equals to x2. And therefore, we go on with the further explanations, where if you happen to find out that the part in green here is not equals to 0, therefore, these two possibility cannot be happens, where the only choice for the multiplications to be equal to 0 will be the first bracket, which is 5k plus 32 is equal to 0. Why it happened to say so is because, guys and girls, let's see the further explanation. Gx is not a one-to-one function, which means that gx1 equals to gx2 will not give us the answer x1 equals to x2. So if x1 is not the same as x2, so in this statement here does not imply means that we know x1 is not equals to x2. So if x1 is not equals to x2, therefore their subtraction will not equal to 0. And therefore I can come up with the answer k equals to minus 32 over 5. Of course, again, those of you without knowing the idea in this statement here, you can still get the answer. But it's important to realize why we need to imply the informations that G is not one-to-one function, because there is a use there that happened. There's a concept happen behind. Therefore, this is how we happen to solve for question 12b.